Okay, hi everybody. Welcome back to the shop, specifically the lathe. Hope everybody's okay. It's a very short video tonight. Something that I've noticed regarding surface finish, particularly when you're using these. This is one of my favourite tool bits. It's the CNMG tungsten carbide. It's C is the shape, N means there's no clearance here, which effectively means you have to use it as a negative rake tool, so it's tilted down slightly, so you get clearance by having it a negative rake angle basically. But it does mean, because there's no clearance on it, you get 8 cutting tips on one piece. Now if you've been watching the sort of carbide versus high speed steel videos, I should give you a bit of background. I'm not a machinist, but I did start my career in a machine shop before moving into aircraft maintenance, and the old boy who ran the shop there was a die-hard, you learn to grind your own high-speed tool bits. We were only allowed tungsten carbide, you know, if we had tough stuff to work on, and a bit like this would be drawn from the stores, and you know, if you broke it you couldn't have another one. And it was kind of brittle in those days. I think it's got better over the years. So I was always a little bit afraid of tungsten carbide, but like a lot of things, when you get to know it, it has its purpose and is very good. If you looked at some of the previous videos, you'll find out that some of the things that used to be true about it aren't. I was always told that, you know, particularly these negative rake tools would put more load on small machines. Well, we did a test a couple of videos back that disproved that. This required less load for the same cut, same feed, same speed, same material, same diameter. Put less load on the motor than a high-speed steel ground really sharp and honed with a positive rake. So, you know, a lot of the old myths about tungsten carbide are not true anymore. These coated inserts cut really efficiently. So anyway, I digress. Tonight I've noticed something that happens with your surface finish as the diameter reduces and your cut reduces. So I'll get my breath and okay, I've been cutting on this. When I was getting a good finish where it's, you know, 1.5 inches across. Okay, as the surface speed has gone down, the diameter has gone down, it's begun to like tear a little bit. And that's not uncommon with some of these slightly tougher but free machining steels. They kind of form a, I don't know, that's not bad, but it's nothing like as nice as this. So that's probably mainly because the surface speed is falling. Let's try another cut, a slightly lighter cut, and we'll see one of the problems that we run into. I'm going to take another 50 thou off that, see how it looks. Right, let's try and get a look at that, because that is not so pretty. We've got these random lines. It's hard to get a camera to focus on this, but yeah, you can see one there. and they're quite hard to polish out. And I think all it is, you notice the chip wasn't breaking quite so well, and every so often it kind of tried to flick over the front of the tool, and that seems to happen. Smaller diameters, smaller cuts. It's partly because of the nose radius, you're cutting more with the front of the tool, and it's partly because I think as the diameter reduces, the surface speed is actually changing throughout the cut. It's running slower at the tip than it is on the further out on the cutting edge, which makes the chip kind of want to roll forward, get jammed in here and mar your finish. Okay, right, I found an angle where the camera can see it. It's not nice, you know, it's okay here, it's not nice here. They take a lot of polishing out, and it's difficult to work accurately when you've got to start polishing out marks. You know, you can polish off little teary bits that are consistent in the finish, but these are not. These are nasty. You don't want them. So one thing that helps, I hope, back off your tool post, rotate just a little bit, let's see what happens. Okay, we'll do everything pretty much the same again. Focus. Another 100th there. What have I done there? Let's touch off. 0. Another 100th there. Let's see how this one looks. Still not great, but better. Much better. So just creating a little more clearance here has improved the surface finish a lot. That would polish up with no problem. And I've noticed that quite a bit with these tools. And if I have to work on smaller diameters, my next favourite tool bit is the CNMG, which is more pointed with a smaller nose radius. I'll dig out one of them next week and we'll see if we can just compare the difference. Okay, that's something doesn't a tiny adjustment that can make a big difference to your finish if you like this CNMG tools. So hope you've enjoyed that short video tonight. Thanks for watching. You may have noticed that now YouTube want us all to have 1,000 subscribers before we can earn any advertising revenue, so please like, share and subscribe. It really does help. Good night.